So very quick introduction because we've kind of already done that. I'm Tom Akehurst. I started creating this open source library called WireMock back in 2011. And I've kind of been working on it ever since, and recently also started building a company around it. So in addition to kind of continuing to grow the open source project, we also have a commercial cloud product. I'll talk about that very briefly later on, but I'm mostly going to focus on the open source and the Java use cases for it this time in this talk. So I'm aware that maybe a few of you might not be aware of WireMock at all, or might not be, sort of particularly familiar with the concept. So I'm going to start by sort of very quickly introducing it and sort of introducing the basic use of it. But I'm quickly going to sort of shift into showing how to use it to essentially kind of test for the bad things happening, the things that inevitably happen to our systems in production, but are not always easy to test for kind of prior to getting into production. So with that, I'll give a quick introduction. So what is WireMock? It's essentially it's a mocking tool that runs an HTTP server. So rather than substituting kind of mocks within your program, substituting objects within your program rather, it will run an HTTP server, and it will respond to real HTTP requests and mimic the behavior of a real API, but obviously giving you lots of control over exactly how it responds to things. But conceptually, it's somewhat similar to object mocking in that you're essentially saying, given a request matching particular criteria, I want to return this response, and likewise being able to say, I want to verify that the system I'm testing made this request out of the thing that's being mocked. So it's built on Java, so it works really well from Java and other JVM languages. But there are a bunch of other language bindings for it as well. I think we're up to about 8 different SDKs, some of which we've adopted and kind of made official, and some of which are just kind of out there in the community, written by people who wanted to integrate with it. You can also just use it via JSON if you don't want to program against it at all. There's kind of a file-based API using JSON, so it's quite flexible in that regard. It's also very flexible in terms of how you can deploy it. So you can run it straight in your Java test code. You can run the jar file kind of as a standalone process if you've got Java running on your machine, or you can run it inside Docker or via test containers if you don't want to run a JVM in order to run the server.
Tom, yes. Quick question: do you is it available via Maven or Gradle, for example?
Yes. So the main jar files are all in Maven Central.
Wonderful. Cool. Just checking. Thanks.
Sure. So yeah, and the Docker images likewise are in Docker Hub. So you find it in all the obvious places you'd expect to find these kinds of resources. The wiremock.org, the open source website, has got great documentation on getting started and shows you, guides you through the various pathways for installing and running it for the first time. So yeah, it integrates very well with JUnit. I'm going to demonstrate a little bit of this in my talk, but there is a JUnit Jupyter extension that sort of hooks into the JUnit lifecycle and makes it very easy to get started. One of the things that I think is particularly strong with WireMock is its request matching system. So you can be very precise, and there's a lot of flexibility around how you match requests. So you can match based on the contents of a JSON body being posted to WireMock, and you can be very sort of general about it and saying, I just want something of, roughly the right structure, or you can be very precise and say, no, I must have exactly this data in order to match this request. And this is useful in kind of building up, many different examples around an API endpoint, for instance, supporting many different test cases. Like I say, we have a commercial cloud edition, which gives you a UI, sort of collaboration, team management, hosting, integration with other formats like OpenAPI and something like that. So I suppose it's probably worth talking a bit about why would I want to use API mocking? Why would I want to invest effort in learning this tool and maintaining API mocks? And these are the main reasons, that we, when we work with APIs, and particularly APIs that are provided by third parties, maybe they're SaaS products or legacy installed software, or something where we Maybe we don't have a sort of particularly direct relationship with the people creating it. We often have a number of practical challenges in kind of maintaining good environments to develop against. We have sandboxes that are unreliable, that are slow, that don't match the behavior of the real production environment. And particularly if you're integrating with lots of different APIs from different organizations, then you add these problems up across many integration points, and you find that you're spending a lot of time fighting kind of just flaky dev and test environments. So that's one reason. Another reason is sometimes API features don't exist yet, but you've agreed maybe with some other team in your organization that a new API feature is going to be built. Maybe if you're a mobile team or a web team and you need a kind of back-end API to be created, then you've agreed it, but you want to be able to continue working and writing your code without having to wait for that back-end team to ship a new version of this feature. So you can get a big productivity gain by essentially kind of parallelizing the sort of front and back end work streams using mocks. Another thing, and this is what we're going to kind of focus on in this talk, is reliably producing failure conditions or things that are hard to get the real API to produce. If you want, say Salesforce's API to give you a 503 on demand, well, good luck. You might get it by accident one day, but you're probably not going to get it when you want it, when you want to test for that case. So another advantage of mocking is kind of going outside of the bounds of what the real API implementation, be it sandbox or production, will give you. And then finally, the reason is speeding up your builds. So mocks are very kind of cheap to serve relative to real API. Typically a real API, when you make a call, might have to go and do database access. Maybe it will call out to other APIs. Maybe it will do some sort of heavy computation of some kind in order to produce the result. And when you're running a large test suite of hundreds or even thousands of test cases, that sort of API latency can add up to a lot. Whereas the advantage of mocking, where you're dealing in sort of single or double-digit millisecond response times, you can bring, I've seen this happen a number of times, bring build times from literally over an hour down to sort of minutes or sub-minute build times for large test suites.
Tom, a quick comment from Amit. He was saying one small observation on the latest version of WireMock 3.2 that has support for gRPC just wasn't available in Docker Hub. Not sure if it's a question. It may just sort of be more of a comment, but it feels like there's a question behind it. So I thought I'd
sure. Yeah. So the way the gRPC extension works, I'll when I get to that stage of the talk, I'll show the layout of it a bit. So it's provided via an extension, and actually WireMock 3 produced it included a new extension mechanism, or a sort of streamlined version of its existing extension mechanism, whereby you could drop extension jars into a file system and have them just be scanned and loaded at startup time. So the gRPC extension takes advantage of that. And when you run within Docker, actually all you do is you mount a directory with that extension file in it, and the Docker image will load that extension and run it. So there isn't a specific Docker image for the gRPC functionality. It's just something you can kind of drop in using an extension file, if that makes sense.
Sure. One quick comment, if that's all right, is when I was working with the Spring team for many years at VMware, the folks that were interested in Spring Cloud Contract, often they had partners, on the other side of a web service, and I think it's kind of unfurling a little bit of what your point is in sort of mocking API features that don't exist yet, or reliably producing conditions that the real API won't do on demand. It's like when they had partners that wanted to, transact with them or interact with them electronically via, some REST service or what have you. Boy, was it really helpful, right, to be able to give those partners and third parties outside of the organization, this spec basically to work with. Also, Pivotal and VMware spent a heck of a lot of time evangelizing test-driven development. And, you're kind of often writing things before they really exist, aren't you? Yeah. When you work that way. So I think those are both also like shades of use cases that you've kind of, shades of gray in terms of use cases that you've sort of hinted at already that we saw a lot, on the Spring team. Thought I'd just mention that real quick.
Yeah, absolutely. And it's probably worth mentioning actually that Spring Cloud Contract it integrates with WireMock, and it will generate WireMock mocks as you're running your contract test with it. So yeah, it's a great example of the somebody taking WireMock and sort of stretching it beyond what was originally imagined and sort of placing it in that new context. But yeah, absolutely, being able to produce things that don't exist yet is the name of the game. And incidentally, it's one of the things we've been working on very heavily with our cloud product is the sort of prototyping workflow. So specifically, the ability to generate documentation and an open API and things like that, kind of on the fly as you're you're prototyping an API by mocking it. One of the things that we've seen, our customers do quite a lot actually is kind of replace the whiteboard with it when they're prototyping. So they'll get sort of front and back end teams into a sort of co-design session, and they will they'll just build a mock of the API as they're discussing it, and then when they leave the room, they've got this working mock, and the producing team have got a reference to work from, and the consuming team have got something they can build against and integrate with. And I think the other advantage of this is the ability for it to facilitate kind of early feedback about the design of the API. So much as we would like to be able to walk into a room together and design a perfect API that does everything that we need from the outset, usually when the rubber hits the road, when you start integrating with an API that's new and has just been designed, you go, oh, hang on, this is missing, or I can't use this data in this format. And the advantage of mocking is it gives you an opportunity to provide that feedback to the implementing team very early. Probably before they've got seriously into kind of implementing it. Whereas the sort of traditional way of doing things, where the producing team have to ship a first version of that API feature, they've probably invested quite heavily in building this feature a particular way, and then they have to kind of unravel it all if the feedback turns out to be that this is not an adequate API design. So there's productivity gains to be had from that as well. That sort of shifting left of the design feedback on the API. Sorry, I realize I'm not actually presenting this properly, am I? Let's try it this way. Okay, so I mean, this is a question that comes up a lot, and given that this is a Java-centric community, it's probably worth answering specifically in this case. Mockito is a great tool. I mean, sort of object mocking generally is a really useful technique. WireMock uses object mocking using Mockito specifically, sort of internally in its own test cases. But I think there are some good reasons why object mocking is not the best solution for a number of sort of testing practices. One being, obviously, you're just not executing your production code, and particularly if you're the microservice or whatever it is that you're building has lots of API integration points, and you substitute those for mocks, then you're actually removing a lot of your production code base and not exercising it when you run your tests, and you're sort of losing a lot of information. And like we said, the sort of traditional approach to this is that you mock your sort of ports and adapters interfaces for this kind of stuff, and then you run integration tests with some real implementation of those APIs. But as we've discussed, you often find that the API sandboxes or the production implementation of those APIs are problematic to work against in and of themselves. They're limited in the range of things you can test, and sometimes they just don't work properly. So that's one thing. I mean, the other one is just this kind of maxim, I suppose, from about object mocking, which is that you shouldn't mock types that you don't own. And I think everybody falls down this rabbit hole a few times when they use object mocking. They'll try and mock. So in my case, I've attempted this several times, but sort of mock an HTTP client via its interface, and you always get it wrong. Particularly HTTP clients, they're really complex. There's all sorts of kind of edge casey behavior that is quite hard to get right, and even if you've got it right in one version, sometimes it will change from one version to the next. How the client reacts to particular conditions on the network, or sort of HTTP sort of protocol elements. So you run the risk of getting it sort of fairly badly wrong at the kind of HTTP protocol level. So I think this is a good maxim to stick to, not mocking types that you don't own. But it leaves you with this problem that in order to get any useful testing done, you probably have to mock something. So this is the solution we're offering here. Where are we? Okay, so just very quickly, how does it work? I mean, essentially what we're doing is our Apple service talks to an API. The API's got a base URL, domain name that it talks to, and we're substituting that in our applications configuration. So instead of going and talking to api.stripe.com, we're going to talk to our mock of api.stripe.com. And the idea is our mock behaves the same or similarly enough that when our app's calling it, it kind of doesn't know the difference. But it's sending the data to this new endpoint. You can also do it via forward proxying. There's some sort of more advanced configurations, but this is by far the most common way of integrating your apps with mock APIs. Finally, before I get into sort of my demo and showing you some code, I just want to sort of introduce the concept of this demo application that I'm going to use. So essentially, it's this BFF, so it's backend for front end type microservice. In practice, it's only got one sort of API route in it, which is allows you to pay for a certain quantity of a product. And this is how it might look in production. You've got a UI application that we call the BFF, and the BFF would make an API call out to this payment service to actually charge your credit card or whatever. But what we're going to do for our testing, for the sake of our testing, is kind of this. We're going to substitute the payment service for a mock, and we're going to substitute the UI for a testing client so that we can kind of drive that service and check its behavior. And yeah, I think that's all I wanted to introduce about that. So let me jump into IntelliJ. I'm cheating slightly here. I've kind of written the code and then carved it up into a bunch of branches rather than live coding from scratch. I hope this will keep the pace of the talk at a reasonable rate, and I'll explain the anatomy of sort of every change that I introduce as I go along. But please shout if you can't read the text properly, or if I'm going too quickly, or there's something that's not clear about what I'm saying.
It's a little small. It's a teeny bit small in the main. Yeah, there you go. Perfect. You're great. That's much better. Thanks.
Cool. Okay. So I'm going to start with this integration test. So this is sort of my main test class where I'm going to run the microservice, and I'm going to run the payment service mock. All of the calls are going to be going over the loopback adapter over the network. So this is real API calls rather than it just happening in memory. So let me sort of walk through how this is working. So this WireMock test annotation. So this is the JUnit integration I was talking about. This is a JUnit extension for JUnit 5. And by annotating a test case for this, it will essentially manage the life cycle of WireMock. It will start a server up on a random port. It will make sure it's running before the tests begin, and then it will shut it down at the end. And it also injects this WireMock runtime info object into any of your test methods, so you can get at things like the port number, and you can get at the sort of the entry point into the DSL for configuring the mock, which I'll get into in a moment. So we have our BFF app. So this is just our microservice. It's really simple. It's using Javelin, which is a really lightweight kind of web framework. And essentially, as I say, it's registering this single route, which is a post to payments. And then we've got this kind of handle payment method, which is very simplistic at the moment. It doesn't have any error handling. Don't worry too much about this at the moment. The important thing here is it's got an HTTP client, which is calling out to our payment gateway API, the thing that we're going to mock. And it's around this that all the action really happens. So if I go and let me just walk you through the rest of this. So there's a bit of setup here. So we start up and run our microservice. We tell Rest Assured kind of how to, what its base URL is, so that Rest Assured can talk to it. And then finally, we kind of get this hook into the WireMock DSL, this mock payment service, and that allows us to configure WireMock mocks. So first, we're going to so this is kind of the good, the bad, and the ugly part of the talk. So first of all, I'll talk about the good. So this is going to be a kind of a happy path test case where we want to essentially model an interaction, but between our client, our BFF, and our payment API that's successful. So this is WireMock's DSL. This is how you configure a stub, and a stub, I think, as I mentioned, is just a kind of request response pair. So we're saying, given in this case, a post request, so with HTTP method of post, if the URL path is equal to /charges, then we'll return this blob of JSON. So it's just a very simple status OK and a charge ID, which we don't care about too much. So we'll generate a random UUID for it. So this is our given part of our test. Essentially, this is setting up the preconditions. Now we do this is the rest assured part. So now we're making a request to our BFF, so to our application under test, and we're essentially making a post to this payments route that we saw we registered earlier, and we're posting a JSON request to it with some quite specific data in it, and we're just checking that we get a 201 status back and that everything's okay. And then finally, the kind of I suppose the then part of the test and the given when then, slightly confusing that the rest assured uses given there, but let's ignore that for now. We can then verify the interaction. So we want to say our BFF should have sent a request to the payment API with an amount field in the JSON equal to 33. This is actually, it's slightly obscured, unfortunately, in this code, but we've got quantity 3 and the price of this product is 11, so it should add up to 33. So this is kind of our the equivalent of our sort of Mockito behavioral verification. We're saying, did we make a request that matched the criteria that we expected? And as you can see, we can do this. This is part of this kind of composable matching system that WireMock has. So we can say we expected the request body out to the payment API. We extract this JSON path element, and then we apply a sort of matching operator of equal to 33. And there's a whole set of these matching operators for working with plain text and XML and JSON, and actually binary as well. You can do binary equality, so it's quite flexible. So if we, I think this test already passes in the code that I wrote. Yeah, so that's maybe not very interesting, but let's break it in some way. Let's change the URL for a moment just to kind of prove that I'm not pulling your leg. And there we go. We see a failure because the URL was wrong. And actually, WireMock does this quite useful thing where it figures out the closest stub to the request that you made if it wasn't exactly right, and it gives you this kind of ASCII diff report and says this was the bit that didn't match. So as you can see, we can see we made a typo, and then we can fix it and run the test again. And that should go back to green. So that's the good. So I'm going to flip back to my presentation for a second and talk a bit about bad things. When we call APIs in production, they are on the other end of a network, and they are live running systems, and they can develop all sorts of problems. They can respond slowly, or the network can respond slowly. The system itself can be broken in some way. It could have had a bad deployment. It could have some infrastructure which is failing. And what this results in, the observable behavior this results in, is sometimes it's the sort of HTTP level errors, so 5xx's. So 503 is service unavailable. If it's a 502, it's a proxy failing. And there's a number of these other kind of error codes that you might have to deal with. Then it could, like I say, it could just be that it's taking too long to respond. So we made a request, nothing comes back. We're sitting and waiting. We probably don't want to make our end users wait forever for something. So we need to make sure that we can handle these cases, and we can do something sensible and not just leave our end users hanging. And then there's things like drop network connections or reset network connections. When web servers are under real pressure, sometimes if they're under a lot of load, then they'll start kind of failing at the network level. So these are things that sooner or later we're going to have to deal with in production, and we'll see the effects of them in production when our code's running there. So really, ideally, we should figure out ways of testing our code before we get to production to make sure that we're actually gracefully handling these things. So let me pull out the next branch in the set, which should hopefully add another test case to our integration test. So if I scroll down here, okay, so now we have this API error test case, and as you can see, it looks fairly similar to the previous one. So we actually, in this case, all we're doing is mocking a response from the payment service, and then making a request and saying we expected to get a 500 error back from our BFF, and but with a sensible error message. The important thing here is that we're saying rather than returning an OK with a blob of JSON, we're returning service unavailable. So this maps onto a 503 HTTP status code. So our mock payment gateway is going to return that instead. And again, I think this one will pass, hopefully. Yeah, there we go. And just to show you so all I did to make that work was to add some extra code in here, which is looking at the response code from from our payment gateway and kind of gracefully handling it, setting our own response code, setting an error message, and so on like that, rather than just allowing an exception to be thrown and the web framework sort of figuring out whether it wants to give you a nice response or not. So that's pretty straightforward. That's a kind of an HTTP level error. I'm going to move fairly quickly on to something even nastier. So so we've done the good, we've done the bad. Now let's do the ugly. So the ugly is when things start going wrong at the network level. So this is sort of at the TCP level rather than the HTTP level. WireMock can do this as well. Again, we have this similar kind of setting up of the stub, but this time we're saying return a response with a false connection reset by peer. So what this means is that rather than responding to the HTTP request as normal, WireMock will send a TCP reset packet, which causes everything to be shut down on the connection, and then that's it. Nothing else will happen. So, like I say, this happens in misconfigured web servers. It happens when load balancers have a bad day. It happens when certain types of sort of web infrastructure gets overloaded. So this is something that you'll probably see in the logs of your production systems if you've not sort of configured to handle it explicitly. And again, we're doing something pretty similar. We're just kind of handling it and saying, do we get payment service fault back rather than error? We could have made that a bit more distinct, but anyway, so that's passed. And you see here we're having to catch an IO exception around our HTTP client. So previously we were just allowing that exception to propagate, and who knows what the web framework would have done with it. But yeah, now we're being deliberate in handling it a particular way. So far so good. But now I want to kind of introduce a more advanced and potentially more sort of useful testing pattern around this kind of stuff, which is quite often when we want to build resilient microservices, for instance, there are patterns we can use to improve resilience, to recover from faults, to handle things in a better way than just kind of throwing an error back to the client. Probably the most common and I suppose straightforward of these is just to implement retries. So if you're making a request to an API and it fails, provided you know that repeating that request is safe, you have to be slightly careful about this. This is probably not a great example in the sense that if you try and repeatedly make a payment, then you run the risk of charging somebody multiple times. But there are certain types of requests, idempotent requests, which are safe, and you want to try and repeat them. So we need to adopt a more advanced testing pattern in order to kind of test drive this behavior in our microservice. But in order to show you that, I'm just going to sort of flip back to my presentation and sort of briefly introduce a new concept. So a feature that WireMock has, which is called scenarios. Scenarios are essentially a finite state machine. So you kind of name a state machine, and then there's a series of named states that it can move through. And what it means is that you can return different responses based on the state of the state machine. So usually WireMock is stateless. Usually the response you get back is entirely kind of a function of the contents of the request. But with scenarios, it's an exception. So you can one of the use cases for it is essentially you can kind of move the state of a state machine on. And if you want to simulate kind of a flaky API, but in a way that's controlled and predictable, then you can say, I want to fail, then I want to fail again, then I want to succeed. So if I've got some retry logic and I want to test that, then if I go fail, fail, succeed, then my retry logic should handle that and should still return a good result. So essentially, so we want to write a test case that kind of does this. So we in our started state we return one kind of error. In our second state we return a different kind of error. And then in our final state we say, okay, we've failed a couple of times, now we're going to succeed. So let me check out the next branch, which has just got a failing test in it. This time I've broken it into two branches, so failing test and then success. So if we scroll down here, so we have a so what we do to create a scenario is actually we create multiple stubs, and we essentially state that they are all in a scenario of the same name. So that associates the stub with with the scenario state machine. And then we can say things like this. We can say the stub requires the scenario state to be started, and when the stub is served, then we'll transition the state to to this next state name. So in this case, we go started, which is effectively first failure. Then we transition to second failure, and then finally we transition to success. And then when we're in the success state, then we can finally return this nice JSON body rather than these sort of errors and faults that we've been returning in the first two. So essentially, fail, fail, succeed is what we want. And crucially, what we're doing here is we're saying we make a request to our BFF service, and despite the fact it's failing a couple of times, we still expect the response we get back from the BFF to be successful. So now at the moment, if I run this, it should fail because the production code hasn't changed. So we get a failure here, and it's because we expected a 201 response, but actually we've still got a 500 error back. So we're still doing what we did before and saying, first bad response we get back, we just turn it into an error, send it back to our client, and that's the end of it. So now if I check out the next step, then this will update the production code. So let me show you briefly what this updated change has done. So we've kind of pulled out the main logic for executing the payment request into another method. And then in here, so this is a really nice JVM library if you've not used it, called Resilience for J. It's just a bunch of sort of lightweight wrappers that give you various kind of resilience patterns, making use of lambdas primarily. So this one here, we're configuring a retry wrapper, saying that we'll attempt a maximum of three requests before we give up. And then we pass it this callable, which is doing the actual work, which is making the request. So this we'll keep attempting it up to 3 times until it succeeds, and then give us our response. So now that we have this, we should be able to run our test again, and it passes. So despite the fact we've had 2 failures, our retry logic wraps around that, and it means that we get a good response back. And this means that we've been able to test drive this behavior. We've done a test first approach to ensuring it's correct, and then we can just run this in our CI/CD jobs, along with all of our other unit tests, and we can we get good assurance that we're not breaking the resilience logic of our code. And there's various other things you can do. So testing timeouts is another obvious one. So you can add a long delay onto a response, and then make sure that if we've got a read timeout configured in our code, that actually it does what's expected. It times out after 2 seconds, 5 seconds, whatever we want to wait for, and falls back on some sensible behavior, rather than, like we talked about earlier, kind of just keeping our end user waiting forever. So that's kind of hopefully gives you a flavor of sort of both basic and kind of more advanced use cases for using these failure modes with WireMock. I suppose another couple of things that are worthy of a sort of honourable mention, that WireMock has a proxy feature where you can, rather than serving a response directly, you can kind of conditionally proxy out to another service. And what this in practice allows you to do is to kind of set up default proxying. So you just pass, by default, you pass requests through to some other environment. But then you can kind of layer on top of that a load of stubs for at a higher priority that will maybe match particular data items or something like that. Maybe you have like a magic email address in a JSON payload that indicates a certain failure should happen. And this kind of allows you to layer on sort of fault behavior onto an API that otherwise won't produce it on demand. So, if you're quite happy with your test environment for your payment backend, But the one thing you can't get it to do is produce errors on demand. Then you can combine the two in this way, and use mocking to just get those kind of abnormal cases added to your test suite. So this is the way some people will use this as well. I'll pause for breath there. Has anybody got any questions or comments they want to add before I move on?
Hey, Tom. Yeah, there was one from Amit in the Zoom chat, and he says, hey, one more question. Today WireMock does have a limitation to support dynamic mapping, stubs created using the REST API across multiple instances of WireMock, specifically in a Kubernetes environment. The in-memory cache is maintained at every instance level, which makes it difficult to scale WireMock horizontally. So I guess, again, maybe more of a comment, but I guess there's a question behind it. So
yeah, so we have been taking some steps towards making it easier to do that sort of thing recently. So version 3 of WireMock added essentially kind of an SPI interface for all of its kind of all the state that it holds. So the reason you can't scale it in its sort of default setup horizontally, or at least not without adding a little bit of extra kind of plumbing outside it, is that it keeps all of its state in memory, and this is great from a sort of performance point of view and a sort of simplicity point of view. But the list of stubs that configure how it behaves, and the request journal, which is used for verification, are by default sort of in-memory constructs. So if you want to scale outwards, obviously you that state would need to be externalized somewhere that multiple nodes can share. But like I say, there is now this essentially kind of this extension point that provides a list of. So let's see if I can. So it's based around this interface here that essentially provides this is a sort of entry point, and it provides a set of stores for each of the bits of state that WireMock works with. And what this means is you can plug in your own implementation, and you can back it onto DynamoDB or whatever Memcache or whatever your sort of externalized kind of state management products that you'd like to use is. So there is a bit of work involved in doing this still, so this is a new extension point. It's also kind of, we've labeled it as beta, and that we may need to add some breaking changes to this as we evolve it, because we're still kind of learning the best ways of doing this. But this does at least provide a sort of a hook with which you can do horizontal scaling, and potentially have a more be more flexible about the sort of persistence logic for your stubs and so on as well. So if you want to store things persistently somewhere else, that was possible via another route, actually a sort of indirect route, an older extension point, but this makes it easier still to do that. So I hope that answers the question about that.
Sergey has a question. Sergey, you can just unmute yourself and jump in.
So couple of questions about authentication. So certain interaction involves redirect, right?
Yep.
Can I simulate in mock a real scenario? Because for example, if you connect to a service via gateway, it goes through authentication and redirect, and in the client I'm testing should process it correctly. Can I reproduce this behavior with mock?
Yeah, absolutely. So a redirect is just a 3xx response. I can essentially just set the response and the headers up appropriately, and that will produce a redirect in effect. So I won't try and run this end to end, because it will probably take a bit to what am I doing. To that, and instead of saying a fault response, we can say response with status. So say if we want to do a temporary redirect, a 302, then we set the status to that, and then we can say with header, and the location header is where you set the actual redirect target. So so I can do something like that. So that will produce a redirect kind of exactly as you expect.
Thanks. And then the second question, can I plug in some SSL certificate to a mock?
So yes, this is an interesting one. So it kind of depends where you mean plug in an SSL certificate. So there is a hook to provide your own SSL certificate when running WireMock on HTTPS. So you can do that. So it ships with its own self-signed certificate. So you don't have to mess around with that if you're happy to make your client trust WireMock certificate. But you have to build a Java key store from your certificate, but you can do that and then provide the location at startup to the key store that has your cert in it, and it will serve your cert with your cert rather than WireMock's. You can also require a client certificate in order to have for the client to connect. So you can provide a trust store that contains the valid client certificates to authenticate against WireMock. So you can do that as well. There's a third scenario where certificates are involved, which is forward proxying, which is where things get really interesting, where essentially to do HTTPS forward proxying, you have to kind of do a man-in-the-middle attack. So we, in that case, generate a certificate that acts as a sort of fake certificate authority. And you have to kind of get your user agent, your client or whatever, to trust that certificate authority. And then that will issue certificates for all of the domains that are being proxied through. So, because we're issuing the certificate, we're essentially faking it. We can then see and alter the traffic as it flows through the proxy.
Sure, thank you. And the last question, does it support the WebSockets?
Not yet. But that is very much something we want to do. WebSockets being essentially a sort of fully asynchronous protocol, we have essentially a plan, and I think this is maybe this, we'll try and do this sort of the framework for this in 4.0 when we get to that. But obviously WireMock is modeled at the moment around this sort of synchronous, one request, one response, as a pair. And something like a WebSocket, it could be that you can emit a whole load of messages without any request triggering them. It could be you can make requests and they go unresponded to. The patterns of interaction are far more complicated. Yeah. So we have this idea of a more generalized sort of asynchronous mocking way of describing abstractly asynchronous mocking. So essentially kind of triggers and reactions where you can you can specify more flexibly those mappings, and then the idea then is it's not just WebSockets. You can do plug it into Kafka or RabbitMQ or whatever, and also you can kind of cross over between protocols. So you can trigger, say, you go and hit an HTTP endpoint, and then you get a message out of the WebSocket, or you push something into a WebSocket, and then it will pop out on a Kafka queue somewhere, that kind of thing. So we are going to work on that, and it will make use of the same core matching system that we use for HTTP, but we need to introduce this very major new abstraction that allows you to, this more flexible sort of generalized mapping between kind of inputs and, sort of essentially like arriving events versus kind of emitted events.
Okay, thank you. No more questions.
Thank you. Okay, so I was going to do a quick aside now and show you something in WireMock Cloud now that we've been talking about faults, because there's a fun and useful feature in WireMock Cloud that kind of builds further on these features. So obviously what I've shown you so far is kind of deterministic sort of mapping of faults. So I give a particular input and I can reliably get a fault back. But sometimes you kind of want something that's more sort of stochastic in nature, I guess. You want to run a soak test or a load test and simulate a sort of degradation of a service in a way which is sort of statistically predictable but not literally predictable, if that makes sense. And so we built a feature in WireMock Cloud for this. So this is WireMock Cloud. This is the kind of editor view. So one of the things you can use it for is just building your stubs sort of with just with an editor rather than code. It's kind of nice for doing exploratory testing as well, because you can go and tweak things on the fly very quickly. But let's say we've got, I'm just going to make something up here. So I'm going to say a get request for /stuff. and I'll return some blob of JSON. This. And if I go back to here, so I'm going to go and grab the base URL for this. So the mock APIs are just sort of on the internet by default. So very straightforward sort of from a hosting point of view. If I say go and make a GET request to stuff, then I get my my JSON back just as expected. Now what I can do is pop over to this chaos mode, which is essentially a randomizer across the faults. So I can produce a failures in a certain proportion of my requests, and I can choose exactly what kind of failures are going to occur. So say if I flip chaos on, and let's say, I don't know, 40% of requests are going to fail, and I want socket close and socket reset, and maybe I want to do 503 as well. So if I save that, so now I hit this a few times, and you see now it's randomly giving me sort of socket errors rather than the what I expected. And there we go. Now we've got an empty reply. So this is for use in kind of load testing and soak testing scenarios. And the nice thing about this is you can essentially say, I'm going to maybe start with a sort of happy path, everything's okay, performance test, but then I'm going to switch chaos on and crank up the failure rate, and just see, does my application survive and stay sort of available, or does it kind of degrade and crash in a smoking heap on the floor? And this is a nice, easy way of doing it. Likewise, we talked about this, but you can add fixed or random delays to this as well. So the other thing you can do is this is something you can do within both the commercial and open source WireMock. But you can add fixed or sort of randomly distributed delays, so you can kind of model the either realistic latencies in the good times for the API that you're calling. Or likewise, you can say, it's Black Friday, my payment gateway is running extremely slowly because everyone's hammering it. So I want to push the latencies up and, again, see whether my application stays stable or not. And I've actually done this for a big retailer over in the UK that I was working for a while, where they used to have real problems on Black Friday with their e-commerce system for precisely this reason. When the payment gateway started to slow down, when the load went up, their apps would just become kind of saturated, and queues would fill up, and it would the user experience would degrade significantly. And testing these things in advance and figuring out where those bottlenecks were, where timeouts weren't set properly, really helped kind of improve the user experience in those situations where it all went bad. So anyway, the very, very brief example of what can be done with WireMock Cloud. There is a free tier for this, by the way. You can just go and sign yourself up with your email address or Google or GitHub and play around with it. So obviously we'd love it if you gave it a try. Are there any questions about that before so I'm going to move on to the gRPC side of things next. But before I do, is there anything else you'd like to ask about on the sort of faults and failures front? I'll take that as a no.
No questions in the queue at the moment.
Great. Okay, so recently I had a bout of COVID, and I was isolating at home, and I got very bored and thought, we've been talking about adding proper gRPC support for a long time, and although there were some kind of open source projects that sort of attempted to kind of bolt gRPC onto the outside of WireMock, there wasn't really something that integrated well with it. So I ended up hacking away on this extension, and so now we have an official WireMock extension that supports gRPC properly, and sort of makes kind of sympathetic use of WireMock as a platform. Essentially, it does this. So gRPC uses protobuf as a message format for anyone who's not familiar with it, which is Google's kind of very compact binary format for data interchange. And although it's very different sort of representationally from JSON, it's actually sort of that it's possible to do a sort of lossless conversion between the two. So you can convert a proto message to its JSON form and back again. So we take advantage of this in the gRPC extension, and essentially it kind of is a conditional filter. It looks at, are you trying to make an ordinary request or a gRPC request? If it's gRPC, then we'll kind of stuff it through the gRPC machinery, and then we will convert it to a JSON request, and then we'll make that to WireMock's core matching system. So as far as WireMock is concerned, the sort of the core system, at least, it's not doing anything it wasn't already doing. It's accepting a JSON request body and returning a JSON response body, but that's being converted to and from it's being converted to and from proto kind of by this extension where necessary. And the nice thing about sort of working in JSON is, like I say, WireMock has got lots of different ways that you can match JSON payloads. You can be very specific or very general. You can use JSON path, or you can use kind of partial or full semantic equality matching. So rather than kind of reinventing all of that for proto, it's far easier to just convert to JSON and then use that. So that's what we do. And skipping too far ahead there. So let me check out the next branch in the project. And they should start adding some gRPC stuff in. I should probably, I guess, to take a quick detour into the build file and just kind of show you what's going on there. So the key thing to note here is that so this is pulling WireMock's core into the project, and then to add the extension when we're doing this kind of embedded style of usage, we've got a separate Maven artifact, and we're just pulling that into the class path. We have a separate integration test. It looks somewhat similar to the sorry, let me zoom in on that a bit. Looks fairly similar to the other one, but with a few important differences. One thing you might notice here is that there's a compile error, and there's a good reason for this, which is that we need to so the way gRPC works is that it has this kind of code generation tool, proto-C, that will take your proto file. So let's look at that first. So we have a proto file that describes the service that we're going to work with. So this is our payment gateway, but implemented in gRPC rather than REST. This proto file is a description of it. So it describes the request and response message payloads, and describes the service and the function that you can call on it. And we need to take this and we need to turn it into something that the gRPC framework can work with. So in order to do that, we need to run these build steps. So generate proto and generate test proto. So if we do that, and then we go back in here, all being well, the compiler passes. So what this has done is it's actually done two things. It's generated a load of Java code, which is essentially kind of client and server stubs for the service we're working with. It's also generated this .dsc file here. So this is a kind of essentially kind of a compiled version of the proto file that you can read dynamically. And the reason we need this is because when we're mocking stuff, we don't want to have to sort of compile in static. You don't want WireMock to have to try and sort of take kind of new bits of static Java and compile them in. That would have been quite a messy way to work. What we want is a service description we can work with dynamically. So that's the reason we compile this in here, and this is a kind of essential part for working with WireMock. There's a reason that we're also using the static Java code, and I'll get to that in a moment. But let me describe this test case first. So remember before we were using that WireMock test annotation at the top of the test. We can use that with JUnit when we're kind of happy with WireMock and its defaults, as we were in that previous case. But when we want some more flexibility, essentially when we want to be able to pass startup parameters and tweak configuration and add extensions to WireMock, we've got this more flexible kind of. So this is the JUnit 5 register extension annotation, and then we can build up this extension class kind of programmatically, and that means that we have all these options at our disposal. And the key ones here are the gRPC extension factory, so they're actually bundles in the gRPC extension. And then we have this root directory, which is basically pointing at where this file is that I was just talking about. It sort of says, this parent directory here, WireMock, has got all the WireMock file system stuff that WireMock should read at runtime. And crucially, it's got this DSC file in it, so it's just telling it where that is. So this is setting WireMock up with this extension. The other slight difference is that because gRPC is kind of service-based, we have the concept of a service, and then a service has got a bunch of methods on it. The sort of hook into the extended domain-specific language for this extension is to kind of wrap this service class around it. So what we do is we say our mock payment service. It's not very well formatted, is it? It's a bit easier for you to see. So we're passing in a WireMock client. So this is just saying, this is the underlying core WireMock client, and we're saying that we're pointing that to our WireMock server. So this is just a way of kind of integrating with the WireMock server running on the right port. And then we're going to give it the payment service name. So this is just kind of the namespaced name, which is kind of used internally all over the place by gRPC. So now we've got this mock payment service. And what this allows us to do is kind of express, sort of more succinctly. So it's important to note that we don't need this at all. We could just use the sort of the core WireMock DSL in exactly the same way as we did for REST, and build up our stubs that way. Because actually in gRPC, it's always a post method, and the URL is kind of built up as a concatenation of the service name and the method name. But we, by layering this kind of extra DSL over the top, we can kind of cut down on the amount of noise in our stubbing, make it a little bit less error prone. And actually, I'll show in a moment, there's some new things we can do that you completely can't do with the core DSL. So what we're doing here is we're saying for our mock payment service, when we stub this method, this gRPC method called create charge, and we want to say, so this is doing some request matching now. This is actually going slightly beyond what our previous example did, where we're saying, I only want to match this stub if I get a request message which matches the structure that I expect. And this is an example of how to do JSON equality matching. So this is saying, I want a JSON document that looks like this, but actually I don't care what these two values are specifically. I just care that they're present. So I'm going to say JSON unit.ignore, which basically means don't care what the value is, just has to be there. So if all this is true, then I'll return a response derived from JSON. And again, this looks pretty much exactly the same as the previous version. The main difference is, as I say, in this case, is that the inbound message has come from a gRPC protobuf message, and this outbound message will get converted back into JSON document will get turned into a protobuf message on the way back out again. And then again, we're back to this essentially identical test case, where we're driving our BFF, and likewise we can do this verification. Now the extension doesn't yet have an extended DSL for verification. This is high on the list of things to do. So actually here we are still doing this kind of URL concatenation, but it does mean that we can still go and check that we receive that correct amount sort of sent to our gRPC service in the way we expected. So what I want to show you next is, again. So the advantage of having all this, so Proxying generates this really nice, nice kind of boilerplate code for working with your gRPC API. It generates a load of sort of service classes and data classes, and also builders and other things that make it easy to work with them. So the other thing that this extension gives you is the ability to work kind of natively with that generated code, rather than doing all this sort of JSON inside strings stuff. So this is an example of exactly the same test case, but instead of working with JSON, we're saying we'll take the builder. So this charge request, this is generated code. So when I did that generate proto, one of the things it generated was these classes. And then I can create a builder, and set the values that I want and build them that way. And likewise, I can do the same thing with my response message. And the great thing about this is it's type safe. It means that it means that when the proto file changes, if I go in here and change the structure of my service and run that build step again, then these I'm going to get compile errors in here. It's not even going to the project isn't even going to build. So it will give me very clear feedback about excuse me, the validity of my mocks. Which is kind of what we want from a statically typed language, right? We want the compiler and the type system as much as we can to tell us when we've done something wrong. So that's kind of the gist with that, really. As we can see, this is just kind of more succinct than working with JSON apart from anything. It's a more readable way of expressing your mocks. The limitation, there's a couple of limitations it's probably worth pointing out with this. One, these have to be exact values, so we can't benefit from that kind of loose matching I was showing you in the previous example. And actually, something I've not talked about very much so far, but WireMock has a templating system for its responses. So rather than just returning canned responses, you can use a handlebars-based templating system and send dynamic responses. So you can template in data from the request, and you can put random values in. You can do wrangling with dates, and you can do logic and all that kind of stuff. So you can't do that with these. This is sort of very much a kind of exact match request to canned response kind of approach, which a lot of the time is fine. But if you do want to do these things, if you want to use loose matching in the request or templating in the response, so there's actually in this DSL, you can just say JSON template like that. That will kind of activate templating, and then here I could say something like that. I love the fact that GitHub Copilot knows how to fill that out. Anyway. So this is a templating function that will just generate a random alphanumeric value rather than the fixed thing that we want. So so essentially, if you want this flexibility, then you need to sort of drop into JSON mode, I guess is the rule of thumb. If you're happy with sort of fixed requests and responses, then you can do it more succinctly in a nice type safe way using the data classes. So one final thing I wanted to show quickly is just that we can sort of putting the two halves of the talk together is we can also we can serve faults for gRPC stuff, and it will work in exactly the same way. So again, unfortunately, at the moment, the extension DSL hasn't quite got this far, so we're falling back on the sort of underlying core WireMock DSL. But again, we can map to a gRPC function by concatenating the service name and the method name, and then we can return a fault like we did previously, and we can get a 500 error back as we would expect. And that's kind of about what I have to say about that.
So I've got a question for you again from Amit. He says for unary response, because gRPC has kind of bidirectional, right? Concepts as well. So for unary response, he says, hey, this extension works perfectly fine. Can we also mock streaming of multiple responses for a subscription? That's
a really great question. And I'm actually really glad someone asked that, because I meant to mention this and would have forgotten otherwise. So thank you for that question. Brilliant. Yes, so it does actually, to a limited degree, support streaming requests and responses. This is something that we want to look at how to expand. Obviously, there isn't a particularly neat way of mapping. So unary requests and responses are easy because it's one request and one response. So that maps neatly onto an underlying kind of RESTful, one request and one response. Streaming is a bit more complicated, but we currently, if your method supports streaming requests, essentially we will just examine each of the messages that arrive, and the first one that matches the the stub match criteria, we will then respond with whatever you configured in the response, and then we will stop and ignore everything else after that. So if you sent 10 messages in as part of a streaming request, and the fifth one matched the criteria, and you had a unary response, then you would get that unary response kind of at the based on matching that kind of fifth item. With streaming responses, I mean, they're supported, but essentially they have to be one message at the moment. So the response you give will be the only message, and then the stream will be ended. This is probably the biggest limitation so far, and we have some ideas about how we can implement this. I mean, we've actually wanted to add sort of better support for multi-part responses in particular into WireMock's core for a while. So possibly there's a case for kind of treating a streamed response as modeling it as a multi-part response kind of underlying, and then saying that the responses get kind of served in turn. Longer term, so actually the like I mentioned, we want to ultimately introduce a sort of a more generalized kind of async model, that supports more complex kind of message-based interactions. And I think maybe the long-term solution for this is that we plug this into the new async model. So then you can, there's just more flexibility around saying matching this one sort of unary input message will produce an output of this set of response messages. But it's one of those things where actually I think it would be great to get some feedback from people actually trying to use it, because I personally haven't done a lot of work with gRPC. I don't claim to know my way around it really well and know what the sort of acute kind of testing pain points are with it. So I'd be very keen to engage with anybody that is doing this stuff seriously, and particularly with streaming based APIs, and to help us figure out what the best way to implement this is.
What if what if you make your framework detach transport from framework itself, what you call matching engine, and plug API from Apache Camel? Then you will have a testing framework for any transport that supports Apache Camel.
That's an interesting idea, having Camel as an adapter. Actually, I mean, I think I like the idea of having a provider framework for asynchronous mocking in general, and we would support a bunch of sort of core implementations, WebSockets being one of them. But then, maybe under that framework, having a provider, which is Apache Camel, could work very, very nicely in that regard.
Because Apache Camel already have several dozen different transports.
Yeah, that's true. That would be a nice way of sort of bootstrapping into a bigger set of adapters than would be possible if we wrote them all ourselves, I guess.
And one business idea. I have one business idea for you.
Yeah.
So in corporate environment, we cannot use cloud directly.
Yeah.
So if you provide a service that you sell using Amazon Marketplace or GCP, Google Cloud Marketplace, corporations could pay for it.
Yeah.
Because corporations usually have access to the cloud. And
I should have mentioned this before.
If your WireMock is available on a marketplace.
Yeah, it's actually on our roadmap to go on the Amazon Marketplace. My co-founder is very keen on this because his previous startup found it was much easier to sell when people could add things onto their AWS bill. The other thing I didn't mention actually is that our cloud product, there is also a Kubernetes edition of it now as well. So if you do need to go, onto your own cluster, either because of kind of data sovereignty or not wanting to work with a cloud product for all of those kind of security and compliance reasons, or if you just want to be able to run things alongside your microservices in the same environment, then we can make available a sort of fully on-premise kind of fully on Kubernetes edition of WireMock Cloud. So that's pretty new. We're rolling it out to the sort of the first of our customers at the moment, but that will I think we will eventually make that available via the marketplaces. So you'd be able to go and pay for it through your cloud bill, and then there would be a kind of self-serve installation process.
Yeah, Tom, that's a good call. There's a couple of vendors out there like Tackle.io and some others that help various companies onboard to cloud marketplaces. But having worked at a couple of cloud vendors, I totally agree with his feedback. It makes a big difference because you've got people with large committed spend agreements and stuff like that, and then you integrate through the marketplace and you can burn down against those. So Amit was just saying thanks for your answers to your questions. He was saying his team uses WireMock quite a bit, using, exploiting almost every edge of the feature. And he says he's, eager to collaborate with, you and the team on gRPC streaming. And I mean, I'm a little rusty on streaming, but I remember, on gRPC, but I do remember there's like a unary aspect to it. And there's like server streaming, client streaming, and there's also even bidirectional. So I was just looking it up, and it looks like Camel has support for gRPC. I'm not sure about something like Spring integration, but yeah, I was kind of, I like his idea, right? It's like they've just got a ton of these adapters out there and a messaging framework, so that sounds like it could be pretty cool.
Yeah, and we're definitely up for leveraging other people's hard work on this rather than reinventing the wheel.
Yeah, I think Apache Camel is, if memory serves, it's relatively lightweight. I mean, I know Spring integration is a library. I'm not sure if Camel is also a library or whether it's like a full-blown runtime or server process. But anyway, whatever.
Yeah, it's many years since I've touched Camel, so I can't remember the specifics of it. But I seem to remember it was something you could kind of stand up inside just a test JVM and run without lots of ceremony. So yeah, it might be a good fit in that regard.
Apache Camel is just a library.
Just a library. Okay, cool. Yeah. That's what I thought. It's been a while since I looked at it too, but cool. Great feedback. Thanks. Is that Sergey speaking? Yeah.
Exactly.
Like
yeah.
Cool. Great. Tom, anything else?
No, not really. I was just going to obviously sort of share some takeaways. I think is.
Yeah. No, please. By all means. Yeah. And folks, any other questions? Jump in, unmute yourselves, jump in, or drop it in the chat as you wish.
Yeah, please fire away. As I say, I'm about done. So if you've got any more questions, then please go ahead.
All right. While they're thinking, go ahead and do your wrap up, and somebody might jump in towards the end.
Sure. I mean, I put these on the screen. I think this is kind of speaks for itself, really. That one of the strengths of WireMock is the ability to simulate these difficult cases. You can really produce much more reliable client code and reliable services by sort of adopting these testing patterns. And they're quite easy. You can do them, run them on your laptop, run them in your CI/CD jobs. While we'd never claim to kind of completely replace chaos engineering, I think the more trivial things that go wrong in chaos experiments, you can kind of shift testing for those a long way left, if you like, and catch them a lot earlier. And hopefully I've shown you a few tactics for doing that today. And like I say, if we'd love to hear feedback on the gRPC extension. It's only at version 0.20 at the moment. We recognise that it's still a work in progress. Particularly around the streaming use cases, I'm really interested to see how we can evolve those. I'll show you a few links. Sorry, I know the page is a little bit busy. The app that I was demoing with is on GitHub, the sort of complete version of it. So you can go and have a look at that if you like. Like I say, you can go to wiremock.io and sign up to our cloud edition and play around with the free edition. Like I say, one of the things it supports now is this kind of two-way open API to mocking editing workflow, which can be great for prototyping mocks. It's probably worth also saying you can push and pull in both directions. So the JSON format that WireMock works with, you can export it from cloud and run it in open source, or you can export it from open source and run it in cloud. And you can so if you started with an open source project, but you kind of want to host it in cloud, and you can just kind of drag and drop it, and it will work, which is kind of handy. You can also point the WireMock client at WireMock Cloud, so you can kind of do all the things I was just showing you, but rather than the mock server running locally on your on localhost, it's running out on the internet on the the domain name you've created for your mock API. So in sort of more like integrated test scenarios, maybe if you're testing like a cluster of microservices together and you want to mock things kind of outside of their boundary, maybe the third-party services that they use, then you can do that, but you can still take advantage of that kind of DSL driven testing if you want to do it that way. And finally, I'll just sort of point you towards our Slack community, which is growing and vibrant, and the core engineering team from commercial WireMock usually hangs out there, particularly during UK business hours. We have some US colleagues who are on there sometimes as well, so we have pretty good coverage in the sort of UK US kind of time frame, and lots of other people that can help you out with stuff, either with the open source or the cloud product. So
thanks so much for joining us this evening. I'm going to stop the recording here.
Great, thank you.